Breaking the wall of antibiotic resistance. Stanislava, Králová. Falling Walls Lab, Czech Republic.
Dear Madam Chairman, dear members of the jury, and dear audience, I am quite certain that many of you already heard an expression antibiotic resistance. And I'm also quite certain that not many of you feel threatened by this term just yet. But don't be mistaken, in 2020, 5 million of people have been killed by antibiotic-resistant bacteria, those that simply defeat the effect of any antibiotics that we can use against them. Unfortunately, this resistance can spread extremely fast through the whole continent, which leaves us with an alarming prediction. By the end of 2050, the number of people killed by resistant bacteria will double. Unfortunately, this problem is even more aggravated by the fact that we are currently experiencing discovery void in antibiotic research. And this simply means that humanity came with exactly not a single novel antibiotic class used in clinical use in the past 30 years. And this is partially caused by the fact that we decided to synthesize antibiotic de novo by chemical approaches, and by doing so we failed. And we built a massive wall between antibiotic-resistant bacteria and our ability to treat these infections. So with my project, what I am proposing is actually going back to the basics. 75% of antibiotics that we currently use have been originally produced by bacteria or by fungi. And these microorganisms do it in their natural condition for one very simple reason, and that's interaction. So they could compete, they could kill each other, or they could protect themselves. And there are several places on this earth where this competition reaches the highest level possible. So I decided to get my hands frozen, and I went to one of these places, which is Antarctica. And here I was searching for those bacteria that are completely novel and can produce novel antibiotics. However, I immediately confirmed one important fact. Once bacteria are brought from environment to the laboratory, they usually refuse to produce antibiotics. And the reason is very simple. Because we treat them well, we keep them well fed, happy, safe, and separated from each other. And by doing so, we miss one important thing from this whole antibiotic production equation, which is interaction. So in my project, I would like to go one step further, and I am actually bringing interactions from environment also to the laboratory by mixing diverse Antarctic bacteria into small microenvironments, where I am leaving them to go through the same life cycles as they do in Antarctica. So they are basically forced to interact, to compete, to kill each other, or to protect themselves in order to survive. And to do so, they simply must produce antibiotics, which I can easily detect by elimination of antibiotic-resistant bacteria. And this is, I believe, the hammer that we can use to crack the wall that we have unintentionally built in the past years. Thank you very much.